Hi, it's nice to be here. Maybe some of you folks have been on the workshop in the morning. This will be a totally different thing, so don't worry, it will be a new topic. So what I'm going to talk about is productionizing H2O models with Apache Spark. Have you ever heard of H2O, or is it totally new for you? Just put your hands up if you heard about H2O. Okay, great, so you heard about it. So let's get to that. The slide says who are we, even though I'm here just alone, but it would be just bad if I would just mention myself. So my name is Jakub Hava, or Kuba. I'm a senior software engineer at H2O. I'm working on core sparkling water. I finished masters in Czech Republic and did some other work. And Michal down there is the creator of sparkling water. He currently is located in the US, and he's also from Czech Republic. So what we are going to talk about today, it's not going to be that sparkling water specific at the start, but we'll get to that. So we'll talk about machine learning lifecycle, because what's important these days, it's not just to train your model, but we need to take that model, put it in a production, then somehow monitor it, get the results back, retrain the model, and just go over this lifecycle and just see what's happening. These days, it's just not enough just to train your model. That's I would say, a solved task. So how we can look at that? We have a few boxes here. The first one is data engineering. What we can think of that? I don't think about concrete platforms right now. I just think about concepts. We can think of other platforms and implementations later. So first, when we need to do some data engineering and clean our data, that's everybody probably does that. We need to filter some data, filter some NAs or pre-compute NAs and stuff like that. Then, once we do that, we create a new data set. Once we have that data set, we can start build a model pipeline. And that model pipeline can consist of several steps. Usually, the first step is feature engineering. It can be automated, it can be manual. We of course will be talking about automated feature engineering. What this means that we can create automatic features for you, so your model we can create a better model for you. That means like automatic creation of columns based on time series, specific domain-specific features, and so on. I'll get to that later. So you have a feature engineering. Once you apply the feature engineering, you get, again, a bunch of new columns which you have in your data set. And after that, finally, you can train an algorithm. And there is shown a small loop down there. That's because you can train the model in iterative way. For example, if you have tree-based models, you train lots of trees, and it's a little bit similar to iterate over something. And once you get that, you have a model. It's a GX down there. That's representing the model. And then you can take the model and run predictions on it. But still, this is not enough. You have the model, and you need to take it to production somehow. So we need to mimic the first half of the slide somehow at the bottom. So we have a X with a dash, X with a small sign there. That's our prediction data set. It can be coming from online streaming from your web page, or from some data location where your data just appears, such as Amazon, Azure, HDFS. Then you need to apply the feature transformations again. Then you need to apply the model and run the predictions. And you have to deploy predictions. So this is what we need to go through to put your model in production. It's just not one simple task. There is several tasks we need to achieve. We need to perform. And because this talk is about sparkling water and H2O, we will show two different implementations how we can achieve this. So the first implementation on the first line will be using Spark for both data engineering and feature engineering. And for training the models, we use H2O. H2O is a machine learning platform written by our company, H2O.ai. Oh, I didn't say that. We are based in Mountain View, but we have also office in Prague. So feel free to come visit us there. And we use Spark for deployment in both cases. However, we use different artifacts both in those two implementations. In the first implementation, we use H2O Mojo. It's our internal artifact how we store models. In this case, the H2O Mojo doesn't store any transformations because those are handled by Spark. I'll get to the second implementation later. So H2O and Spark, it was the obvious naming we had to do. It's sparkling water. We tend to name our products. We like water. So why H2O and Spark? Why sparkling water? H2O is a machine learning library. It's written completely from scratch by our core engineers. We have really smart guys in our team. It's kind of amazing if you have Rob Tishirani and Stephen Boyd looking at the same code when we're implementing GBM. It's like amazing brain power at the same place. And it's mostly written for machine learning experts. You need to really configure your parameters. There is lots of configuration you need to take into consideration. And sparkling water, it takes the best out of Spark and H2O, and it exposes the nice Spark API to Spark people, whilst we can still run H2O algorithms underneath of that. So what I'm going to show right now is the implementation of the machine learning lifecycle using sparkling water, and then I'm going to show a quick demo how it's done in practice. So we can see that it's divided into 3 boxes. The first box, the orange one, represents the feature engineering and the data engineering. So we use Spark for both those tasks. We can think of that we just load data to Spark and we do, for example, like Spark data frame filter. Or Spark data frame map, and we just filter rows we don't want. For feature engineering, we can again use Spark transformers available on Spark pipelines. They are not that powerful. As hopefully as I think we do in driverless AI, but they are there. But in the next stage is once we have the prepared data, we go for H2O wrapped inside sparkling water. And we train the algorithm. Again, in interactive way, we can train GBM models, KB models, deep learning neural networks. So once we have that model, we have the model artifact which is called H2O Mojo. That's the outcome of model training. And then we can put it into production. But the model artifact is not just enough. Here, because we did some feature engineering and model training, so we need to wrap it somehow all together, because we want to deploy both the feature transformations and both the model training. We just don't want to deploy model training because then we would lose the data preparation steps. So we wrap everything into Spark pipeline. That's the box down there. And it's separated into 2 because it has 2 parts. The first part is Spark transformations, and the second part is H2O Mojo model, which will be used for predictions. But it's all wrapped inside one Spark pipeline, one artifact, and you can deploy it like that. So let me just do a quick demo how you can create this Spark pipeline with H2O Mojo inside. And we'll get back to the slides afterwards. So I prepared myself a small notebook here. I'll just go over it quickly. The code is not that important. Let me just run all the cells. Yeah, perfect. So it's using Spark, it's using H2O. I'm just verifying that I have Spark available. Here I'm importing PySparkling, which is our Python client for sparkling water. I'm making sure that H2O context is running. H2O context is necessary for playing with, for submitting H2O jobs to our cluster. So we can see it's running in our time zone. We can also go to our user interface. Let's get back later. And what we need to first do, it will be a really simple demo. We'll just load the dataset. Oh, I didn't mention on which dataset we are working on. That's important. So what we are going to achieve here is that we have an internal dataset which tells us how I will introduce the product later. The driverless AI, it's a product which we use for automating machine learning and feature engineering tasks. And internally, we have this data set which contains measurements of how long the different driverless AI runs took. So for example, when we know information that when we run on Mac OS, we had n number of features, we had that number of categoricals, so that data set took us 2 hours to process. So we will try to predict how long it took us to process that data set. So it's some kind of meta predictions, but it's not important. So this is just introduction to the data set. So what I'm gonna do here is that I'm gonna filter the rows where the number of input rows was more than 100 because we are interested in a big data set, not just the small ones. The next thing I do is that I prepare H2 AutoML step. If we imagine the boxes, that's the second box. The first one, this one was the first box. This is the data cleansing we do in Spark. The second box is the data training, the model training. This is written by H2O, and what it does, it will, in a given constraints, in 1 minute, try to find the best model automatically. So it can discover either GBM or XGBoost or deep learning is the best model for you in this case. You don't need to worry about that. Once we have that, we define the pipeline as simply like this. We load the data set. Don't worry about the name. We have been presenting similar talk on Spark Summit in San Francisco. It's the same data set, but it will just do fine. So once we have the data, we can just do some conversions and just fit the pipeline. So here, with the H2O Spark frame call, what we are doing is that we loaded the data frame as H2O frame. And H2O and Spark has different implementation of frame structures. So what we are doing here, that we convert that to Spark data frame, and we train the pipeline on that data frame. And what the outcome is the model, pipeline model. And the model consists of all the data cleansing steps and the training steps. So when you run when you give it some input data, it will go through every stage. It will process your feature engineering tasks and both training. So we have one simple artifact which you can deploy, and it contains all the steps. And I'll show how to deploy it a bit later, together with the second demo. So we explained these boxes. Yeah, we already did that. And other product. Let me go a little bit back. This will be the second implementation, again provided by our platform. But this time we used Spark just for the data engineering, so just filtering your data. But for the feature engineering, for example, inferring or creating the domain-specific columns, we use H2O driverless AI, which is product, which I'll show in a bit. And it's used for automation your machine learning task and feature engineering tasks. It will give you the best model, again, within the given constraints. Compared to AutoML, it does feature engineering. AutoML in H2O, it doesn't have feature engineering. We can then use Spark for deployment, and in this time, the model the artifact which comes out of this implementation is called H2O driverless AI module. Why it's different? It's different because this time it consists of feature transformation steps and the model training. Before it was Spark and H2O, right now it will be just one H2O artifact. So let me go to that slide. So H2O driverless AI. So the slide said that, what if not expert? I should go for H2O driverless AI. It can help companies to automate the task. If you don't have like big data science department, this can definitely help you automate the tasks. You don't need any expert knowledge. It will do everything for you. It can discover time series columns. There is lots of magic hidden inside. And mainly the automatic feature engineering. There is a bunch of Kaggle grandmasters under this project which are working hardly on making sure the transformations are working as expected in the given domains. So how the implementation would look like with having in mind what I just said. This time, the orange box represents just Spark, and it's used for data cleansing, filtering your data. The driverless AI will take care of the rest. You will upload there the data set, it will do feature engineering, it will train the model, and it will give you the model artifact called Mojo pipeline. And next, if you want to deploy it, we have the Mojo pipeline, and we can wrap it as Spark artifact. It's just simple technical task, but why it's important is that we want to be consistent. We want to deploy sparkling water pipeline and Mojo driverless, H2O driverless Mojo in the same way. So we just wrap it as Spark pipeline, and we can deploy it in a very similar way. We actually don't need to change our code. So how it looks in the demo. Let me go here. So this is a driverless AI. I have here a data set which I can click on. I can run predict. I need to select the target column. It's a T total because we are predicting the maximal time we want the driverless AI will run on some specific data set. We can tune the configurations. For example, we want to say, okay, I want to get maximal accuracy. That means that I can have different transformations. It can use different models. I can give it more time. If I give it more time, that for example means that driverless can internally decide to use more trees, or try more time demanding algorithms. And also interpretability. This is kind of a big topic these days, because if you want to sell something to customers like banks or insurance, they need to be able to explain what happened. For example, if you apply for a mortgage and you don't get it, you should be able, and you should do that. You should ask your bank, why didn't I get the mortgage? And your bank should give you the results, how your machine learning model, which path it chose, and they should be able to explain. Thankfully, we have finally laws for that, so they are obligated to do that. But that's why this is important, because there should be transparency in your data. It shouldn't be just black box. So you can even choose how much interpretability you would like to get. For example, if you choose lower number, it won't use complicated feature transformations. It will use just simple human readable transformations. If you go for higher, it can just create random. It would look like random transformations, but they make sense, but they are not human readable. I can also enable GPUs. Driverless AI will work on GPUs. So if you have GPU or GPU box, for example, from any vendor, you can run on that. It will definitely speed your tasks up. If I start the experiment, it will start reading the data set. It will start running the feature transformations and model training. This will take a bit because there is not good GPU inside of this laptop. So let's just believe this will end. I have prepared the model in advance. This will take like 30 minutes with the given settings. So let me go back to slides. This is just I just show you that, so we can skip that. This picture is interesting. Here we can see how many feature transformations driverless AI actually does. This is a simple network on the left, which the input are the original features. There is like 20 of original features, and it creates this dense network of the feature transformations. And it does that all because we want to give you the best model. And this is just, it's not possible for the human brain to keep all these connections in mind. So that's why we do that automation. And this is just on the right, we can see how it's zoomed up. So there is really lots of connections. So before I show you how to deploy it, let me just show you how this lifecycle should be, how it should continue. The model deployment is just not only the one thing. We should also have something so-called auto-documentation. We should be able, the model should be able to write somewhere and explain it somewhere there. Because again, if you train more models, you should be able to store, you should be able to have somewhere the information about what the model is, what is this model about, what is the original data set, and stuff like that. Also, we should have some model management. The model should be stored somewhere. We can keep it as simple as some database, but it might be, for example, smarter. It could be some interface where you could do some meta search over your models. For example, I would like to search for all the models which I trained last year, but I use entries. The entries are parameter between 30 and 50, and whatever the AUC was the best. So just find me those models. It's great for reproducibility. If you have lots of models or you have a big data science team, I bet your data scientists will just try stuff. And then you will end up with 100 models, and at one point you will just don't know, you won't just don't know how you got this model, how you configure it. So this is perfect for reproducibility. And also important thing is model monitoring. And that's important because you need to be able to monitor your deployed model. For example, if your data distribution changes on the input, you should be able to determine that, because if it was like 60 to 40% if you do some binomial predictions, and it changed to totally 80 to 20%, then you need to be able to discover that. Otherwise, your model is just doing something wrong, really, really wrong. So the model monitoring should be able to run as part of the model, deployed model. It should output some monitoring information which in idle world could be automatically applied at the beginning of this pipeline, and you could retrain the model automatically. But let's show how we deploy these things first before we continue. So we have this will be. Can you see that? Maybe a little bit. So it's not important, the command is not that important, but I'll just explain what I do and I'll show you the code afterwards. So what I'm doing here is that I will deploy both pipelines, the original one and the second one, using this simple script, and I'll show you the code how I did that. What it will actually do, it will load the sparkling water pipeline and driverless AI pipeline wrapped as Spark pipeline. It will start reading for our public S3 bucket as we are writing there periodically some data from our monitoring runs, and I'm going to run predictions on that. Oops, wrong environment. So just give it one more second. I didn't have a correct Python package, so I just need to apply the virtual env. What it's doing now is just starting Spark. It's deploying the dependencies on the Spark cluster. I have just one local node there. It's a really small cluster with 4 gigabytes of memory. So what we should see in a bit, that Mojo was loaded and driverless Mojo was loaded. So both pipelines have been loaded, and we will right now run predictions on them. It will take a while to show the first results. We can see that it has 3 columns. The first one is time step. We can think of that as an ID. The second is the predicted time in Spark. That's what Sparkling Water pipeline predicted. And the third one is what driverless AI pipeline predicted. We can see that the results are a little bit different. It's because driverless AI did some extra feature transformations, and it chose different models. For example, XGBoost. So you just saw some numbers, but you don't believe me that I just didn't create it up. So let me show the code. Score both pipelines. So can you see that? It's a Vim environment, but I think you should be able to see that. So this is just technical boilerplate we don't need to worry about, but what's important is this line. the pipeline model.load loads the sparkling water pipeline we saved as part of the simple first demo, the sparkling water demo. And we can see it's not H2O specific. This is normal Spark class, Spark pipeline model class, and we load the sparkling water pipeline, which is enhanced, and it's using inside H2O algorithm. For the second demo, where we use driverless AI, we use this call, H2O Mojo pipeline create from mojo. What this call does, it will take the driverless AI mojo with both feature transformations and model training, and it will create Spark artifact out of it as well. I need to define schema. I can do it also using small hacky way. For example, if I would save the schema from the original dataset, I would need to have to specify it manually right now. I could just use the exported schema, but I just decided to use it for simplicity right here. And these two lines are important, that from this S3 bucket, I will start reading the data, and I will keep applying the transformations on both pipelines. The first one is using sparkling water, the second one driverless AI. The API is the same. We don't need to change our code from this line at all. And again, we will start writing to memory. The output we saw in the console was the output of these two calls. And it's running automatically. When your new data comes to the bucket, it will run the predictions on the data. So it's perfect for automation, your predictions, for example, from clicks on the web page, or new files appear in your HDFS. And this is again just a boilerplate. So let me go back to the slides. So we already covered that. We are also in H2O working on the model management bit and the model monitoring bit. But I won't be showing that today. If you are interested in materials, you should be able just to scan this QR code, and it should get you to GitHub page where you can get some additional materials and links to our books and so on. I guess that these slides will be also shared afterwards, so you can probably download them. I will just wait a bit. Perfect. I will return this slide. I will keep the slide there. So I guess I finished a little bit early, but at least we have time for questions. So thank you. What the outcome is here, that sparkling water is not just product on its own. It's really integrated into our platform. It's integrated nice with H2O and driverless AI. Important to say is that sparkling water is open source. H2O free is open source. You can download it. You can download it from our page. You can download it or fork it in GitHub. You can build it yourself. You can even use it inside of your company. How we make money? We provide enterprise support. The driverless AI product is a licensed product, and for that, in order to be able to use it, you need to purchase a license. And also, before we go to the questions, I would like to announce the event which is coming in end of the October. We are holding a big conference in London in 28 and 30 October. It's 2 days of H2O use cases by our customers from US and Europe. Also, lots of Kaggle Grandmasters will be talking about application of data science in H2O, and lots of smart engineers will talk about how we do things. So if you don't have any plans for last week in October, you have 50 free tickets. It's whoever comes first, they can get a ticket, and it's in London. So I think this slide should be kept here. So thank you very much. And we have some time for questions. So if you have any question, I'm happy to answer them.
Thanks a lot, Jakub. Вы успели записать ссылку на промо?
I can put it there.
Thanks. Do you have a visa in London? Hands up. Who has?
I know it's a little bit last minute, but you never know.
Nice. Do you have a question?
Hello, nice talk. Question is, if we have existing Spark cluster, how we can integrate it with the H2O cluster? We should run H2O on our existing cluster, or should like create new one and push the data from one to another cluster, or how it should be done?
Okay, that was a good question. So the question is how you integrate H2O, or how you deploy H2O with your if you have existing Spark cluster, how you incorporate that with H2O. So you can use your existing Spark cluster, and important code is this one. What you just need to do is to put Spark motor jar. It's a jar file. It's implemented in Scala, so it's a jar file, and you just put it on your Spark class using jar or specified packages. And it will automatically put all the dependencies on Spark class. And if you want to enable H2O or Spark motor capabilities, you just call this H2O test get or query. And you can still use your existing Spark cluster, because we realize that if some customers or open source developers want to use Spark and Motor, they should be able to use their existing clusters. That's why we do that integration.
Thank you for your talk. And could you please talk a little bit more about, you told about automatic features in engineering. So kind of how do you do that? What level of sophistication can we expect from those algorithms or something? Thank you.
Thank you. So the question is how much sophisticated is our feature engineering? Here I will have to disappoint you. I don't know much about feature engineering. I'm not part of the driverless AI team. I'm more working on the integration of these platforms and making it parallelized. But if you would like to know more about which kind of feature engineering we do, we have lots of materials on YouTube. So I definitely suggest you to check it out, because it's those talks are by the Kaggle grandmasters who really know their topics. So I would better keep this on them.
Thank you for your talk. And just to better understanding, Spark Inverter is just a connector to pull data out of Spark cluster. You feed your algorithms in memory. It's not like a distributed algorithm. Am I understand it right?
So the algorithms are parallelized completely across the whole cluster. We have two deployment modes in Spark and Motor. It's a technicality right now, but always parallelized. If you have Spark, it's parallelized inside Spark cluster. We have also different mode, but again, fully parallelized.
Okay. So have you compared performance of your parallelized algorithms with more conventional, usual in-memory, single machine algorithms performance?
When it comes to big data, this basically answers itself, because if you have 1 terabyte of data, you don't have 1 terabyte of. If you have machine with 1 terabyte of memory, then I guess you're lucky. But then we need to parallelize somehow. And basically, if you have file which has 1 gigabyte, then everything will work fine, because there's no scale. But if it comes to big data, we think that H2O will start doing its job, and you will see the results. But the best thing is just to download H2O, give it some big data set and try it out. We don't provide any public benchmarks, because we do not believe that we should do that, because then people might think that we do just that to show a nice image. But there is also a repo from Sillard, a guy from Poland. He does amazing job with benchmarking Spark and Motor and H2O. And it's an open source developer. He has no affiliation with H2O. So I would suggest checking that repository.
thanks for your talk. When you have shown how to create model like without driverless AI, I've seen that there is something like AutoML that do all the job in one line. And all the other lines go about infrastructure. So my question is, what's the difference between AutoML that do all the job and the driverless AI?
Let me just show that. Show it. This is a good question. So the question was, what is the difference between this AutoML step and driverless AI? So this is sophisticated, but compared to driverless AI, it's still very simple. This doesn't do any feature engineering. This will just, you will tell it, I have 10 minutes, and it will just try to find best model. It doesn't do anything as smart as driverless AI. Driverless AI will create new features for you, which can highly influence how the model performs. But this is for open source developers. Driverless AI is for this licensed product. Again, I would suggest checking out our, for example, Mario's talk about feature engineering, or Dmitry, who's our calculator masters and really knows this stuff. Did I answer that question?
So, Jakub, thank you. Applause for Jakub.
Thank you.